Hello, everybody. So tonight finishes up midterms for our course. A lot of your other classes, it probably finishes up the course. So a couple things. I had mentioned earlier, I mentioned at the end of the other day that the plan was going to change. I think last week and maybe at the beginning of the night Tuesday, I mentioned that my original plan had been to do a big example and look at everything we've seen so far in action tonight. But that was going to be a full night, and then Tuesday night ran a lot longer than I planned. And this time of the semester, especially on the Thursday night class, you either, in week 8, you either have a lot of stuff to do for your 8-week classes and midterms, or you just finished doing a lot of stuff and are anxious to get to the break. So I thought it would probably be better as a short night, especially since we were here late the other day. And I kind of mentioned it the other day, if you remember, it was near the end of the class, so it was probably the getting tired time of the evening. But since I thought the other day to push off that example until after the break, and well, it was kind of a short class tonight, because Thursday night class on week 8, I know everybody's tired and you either have a bunch of stuff to do, or you just finished doing a bunch of stuff and it's time to relax. Yes, Alice in the chat room, there's no classes for us next week either. Your 16-week classes have a fall break, a week off, and then a week between the 8-week classes. So it's time to relax for most people after our class tonight. Yeah, next Tuesday, we will not have, we won't be meeting next week. School's closed for fall break. Or the most of the staff will still be here in the front offices, in particular advisors and admissions, and the people that are really, really busy the week before semester starts. They will definitely be here. They'll probably be working late every day next week. But for most everybody else, it's a week off. A week to relax. So I assume you're probably ready to get to that. So that long, full example, I thought we can push that back. And then as I thought about that more, I thought, well, that's even better after the break, because then after a week of relaxing, we'll start with a full example and see, kind of look at all the stuff we looked at over the last couple of weeks in a situation instead of just a syntax example as a review after the week off before we move on to MySQL stuff. Because the next section we're going to get to has us using another programming language inside of our Java code. So the first night after the break is probably a really good time to review everything we've seen in Java so far. So I went back and forth trying to come up with something to do for this evening, and then I realized, well, I do have something good to cover, because one, at the beginning of the semester, we kind of skimmed over the GitHub stuff really quickly. I assume most people have seen it or heard of it, and if not, what we need to do in class, we can use that web interface drag and drop. We'll get some GitHub stuff real quick. And then the other one that I realized that we haven't really looked at, I'll point at the name of the class. Go to Ivy Learn. For sure it's written on here. It's kind of a roundabout thing in the name of our class that you would have looked at, probably completely ignored. But, well, I guess it's abbreviated there about the middle of the page. This class is software development with Java. This class isn't Java. It's not the Java class. It's software development class. We're just using Java to study software development. So that little subtlety, there are some points about just general software development points that relate to going over GitHub that we can look at tonight, this evening, and make it a short class, probably sooner than we normally have a break. For the evening, we'll be wrapping up for tonight, and that way everybody can get started on the break, or y'all can get started on the break. I will be sitting in my office working on finishing up the classes for the second 8 weeks, which are all ready. I just have some typing left to do. I have the plan together, but that last tedious, little boring part, kind of the software thing, right? We don't get paid really good money to sit and type. we get paid really good money to think really hard about a problem and solve it. And typing is just the tedious, busy work at the end. Programming is not a typing thing. A lot of people kind of misunderstand that, but let's throw together an example, a little trivial example of software to look at the software points. And then we'll do a thorough example on things we've looked at the last couple weeks afterwards. Maybe I'll throw a couple things here just to have more than one file. I'll make a new project. I'll just stick with an one that has be clicking around in folders quite a bit. So give it some sort of name. I'll call it software because it's coming on fall break. So starting to get a little tired and not as creative. Probably have more creative names when we get back from the break. Get all this stuff out of the way. And yeah, this doesn't need to be anything fancy, just a hello world application, but I think I'm gonna do it in pieces because we've seen multiple pieces and to make it more representative from more than one source file here. So I'll start by making an interface that sets up our rule. Make a new interface and a rule for this software. Any classes in this software have to implement some method. I'll just call it software rules. Software interfacing rules. I'll go ahead and spell out what it is. Not quite our full review yet. We'll see this in action next week. This is going to be a little hello world thing. I guess that can be our rule for this piece of software. Anything here, any objects we make for this need to have a public string method called say hi, the whole print hello world thing. Probably won't need any parameters passed into it. That gives us our interface, our rule for the objects in this software to follow. So we'll have some of those in a large piece of software, more realistic one that we will see next week. Although still somewhat a bit unrealistic. I think I mentioned the point earlier. I like to say it a couple times in the semester. In a classroom, we are under very tight time constraints. I think everybody's well aware of that. So anything that we do in a classroom, as far as learning software development, has to be small enough to fit in the time constraints we're under. However, the world at large has kind of moved on past the small programs. The world, software development at large in the world had those small problems that we can address in a classroom solved by the early 1960s. So there's that big gap when people get the degrees these days for something programming, software development, or engineering, or computer science, or one of the code heavy degree programs in technology, and then moving to the working world, because all the way through education, you're doing small things that fit into time constraints. And then you get out to the world, to the real world, apply, do the whole interview process, maybe a couple of them, get a job somewhere, and you get assigned to your first project and suddenly find it's not the small questions like you see in the textbook. It's something that 10 people have already been working on for 2 years and they still haven't figured out a good algorithm. And you're just another one contributing, another mind to contribute to that. Right? An extra set of hands and eyes to work on a really, really big problem. So be prepared for that as you graduate. It's not a subtle step up from what academia can do with programming to where the careers in programming are. It's still the same concept. You're using the same language and stuff, but there's kind of the problems escalate quickly between academia and the real world. And hopefully it makes sense as to why we can't fit those problems in a classroom. People with decades of experience in creating algorithms have been working on some of those problems for months or sometimes years, and they're still trying to figure out a good algorithm and back and forth and looking for improvements. So the problems will grow. But our software is going to be more than just one file. That's why I didn't want to just print hello world. So I'll set it up. It's a short list of things for our message. I'll make an enum. I'll add an enum to that just to show a quick reminder of some of the things we've done, not the full review yet. I'll call it greeting. Yeah, that's a good one. And make a short list of types of greetings we could have. We have a simple greeting, which will just be the hello world. Bugs Bunny greeting. German greeting, say hello in German. Hello is a German word. Sorry, hello is a German word. Said that very wrong. Hello is a German word you may have noticed, or just it usually slips Americans' mind that English people don't say hello unless they've lived in America for a while. So Germans have lots and lots of greetings. So I'll say Guten Tag or something like that, one of the other ones. What's another? I'll say American greeting. They're walking past in the hallway. I walked past several people in the hallway today. We all had the same reaction almost simultaneously. So like, hey, and a head nod, and that was kind of the whole conversation. Because we were, I was just getting to campus, and they were finishing up their days. I guess finishing up their work, and we're just getting their daily steps in. Right? After hours of sitting at a desk, get up and walk circles around the hall. Make sure the fancy watch says they got enough steps in for the day. So the greeting is just like hey and a head nod. So a couple simple greetings that we could return. A short list, though, that's what an enum is. We're going to enumerate it, make a countable list. Countable doesn't necessarily mean we have numbers, so in some languages it does. Some of the other members of the C family, we can actually do math with the things in the enum. The one written up to the left is 0, and the numbers increase. For Java, it's just a short list. And in Java, the ones we can do math with, we can't put methods in there. We just have the short list. Makes the code look really nice. Java will let us put methods in there, so we can have some simple returns on these. I'll make a public string method called getGreeting. And we saw earlier that whenever we do this, a nice way to do it, since we have a short list of finite, definite things, a switch case is a really good structure to put here. So we'll switch on our keyword this. So we'll look at our object itself. Let's see, what do we have? We have a case for simple. Personally, I always write all the cases and then I come back and do what's in between them. I guess it's kind of like that thing I do working down the columns instead of across. Change the overall mindset fewer times. Or you don't change your mindset every single line. Like first off, think about all the cases we have. Case German. Oops. Case American. And please don't forget to put a default case in. Yeah, I'll go ahead and say it directly. For the 2 people that have already turned in part 2 on the midterm, keep in mind, please don't forget to put a default case in. That won't throw an error, but on the 2 people that have turned in the part 2 of the midterm already, I've looked at them, so make sure all cases are covered. Because if there's a case not covered in the switch case, you get an error. So make sure every number that's going to be passed in does go somewhere, or that you have a default case to fall back Our default, I'll just return hi. The basic one. And then on some of the others, I'll return simple, sounds like the hello world. Our basic one, Bugs Bunny, return, what's up, Doc? Bug greeting. German people have lots of ways to say hello. There are lots of ways to say hello in butcher. It's smaller than other European languages, but they have a very, very large number of ways to say hello and refer to as the butcher. I guess they like, yeah, it says a lot about their diet there. I'll say Guten Tag or Guten Abend. It's evening. That's good evening. And the American one will be return with a head nod as people pass in the hall or on the sidewalk or something. Oops. I can't remember if we saw it this way or not earlier. Notice how it didn't put any break statements in there. When we hit a return, that it leaves the method. So with return, we don't have to break that afterwards. If we do anything other than return, remember to put a break. You have to actually break out of your switch case. Otherwise, it'll run every single case afterwards because that switch has been flipped on. So either break or return on your switch cases. So now we have a rule that we have to say greeting. I have a bunch of greetings to choose from, and I'll go ahead and make your class to new Java class called hello. Can't really think of much there. Just gonna put a method here. Nothing too fancy. So one data field, a private greeting sort of data. I'll call it greeting. And insert a constructor. Oh, yeah. Then we made an interface, so we need to make sure our rule is followed. Implements software interfacing rules. There we go. It helps to spell implements correctly. And you may have seen me do that a couple times this semester. I've been casually avoiding fixing it, but that's a word that I regularly spell wrong. Keep an eye on things like that. If there's like keywords and stuff that you notice that you just have a tendency to spell that word wrong, keep it in your mind. Because especially if it's a keyword like implements, it's going to show up a lot. So I've just gotten in the habit over the years. Something about typing those letters, I very regularly miss the M in the middle of that word. It's just a mistake that I know I regularly make, so I keep an eye out for it. So as you get practice in your classes, keep an eye out for those. I'll set up a constructor. I'll just make the default constructor and then public hello, one that takes in some greeting data. So all things we've seen before, right? Nothing too fancy here. And I guess I'll just do a getter method because for this simple case, all we're going to do is print. We're doing a really, really complicated print hello world on the screen. but showing off, looking at some of the other parts to remind you about how they fit together. So we need our getters and setters because it's actually private data that we make. So we turn that enum into. So I'll a public greeting, get greeting. And return greeting, but greeting is an enum, so I'm going to take this a step further and just bring the string back at this point. So that's what the normal getter would look like, right? But we can, if we know there's another step, we're the one writing this code, we can, we know that other step will always be right here. So we might as well go ahead and carry it out here instead of just that default get accessor method. So a few things, but we're still missing that requirement. Anybody remember that? Or did it already slip your mind? Hopefully it slipped your mind. Maybe not hopefully, but for the point of the example, the reason that was explicitly stating it is that was what, 5 minutes ago? And it probably already slipped your mind. That's one of the big advantages of the interfaces, even in your own code. It's like, okay, I know I'm going to need this later. I probably won't get around to typing it for a minute, so I'm going to go ahead and set this rule to remind myself later that I need that. It can help with that. Yeah, then we need to override that method. I was just typing everything tonight for some reason. All of this code could have been generated, right? Except for the edits on that one. So we need a public string method. Oh. We need to override a public string method called say hi. That returns a string and we'll return, I'll do it fancy, this dot get greeting. Because we already have something that digs through and that grabs it from the enum. So I'll just call our class method that digs through and gets it from the enum. And I guess now we can go ahead and create an instance of this and call that class. All of that should look very familiar by now, right? Things we've seen a few times. And just stretching out the context, because Java is for big things. So anything that fits in a classroom kind of feels like this. It's like instead of just printing the words hello world, we went through all of this other big ordeal to get that stuff out there. So I'll make some hello data. Call it hi, is new hello. And for our constructor, we need to pass in one of those enum types. And enums are static objects, so we need the name of the class, greetings dot one of these, maybe Bugs Bunny. Yeah, I'll just print it out. I dot say hi. So a really fancy, really complicated way to write hello world on the screen or something like that. And a lot of the stuff we do in the classroom, it kind of feels like we're doing this with Java. We're overcomplicating things that could be simplified. But remember, just please remember in the long run, when you get to projects that don't really fit in an 8-week time frame, Java is for very big things, and then the advantages to this show up. Like for example, a classic joke about Java is a knock joke with Java. You might remember I started the class out with that. But there's a classic knock joke about for Java code. And goes knock knock. Who's there? Java. Java who? Java programmer. That nice long delay. For something like this, what that is the Java virtual machine has to spin up. And it takes a little bit of time for that to do it. So if we're waiting for this a full virtual machine to spin up, that's going to be a long wait to print the words hello world. But if we're doing something massive, like was it 3 years ago when that lady took a picture of the black hole? When did you do that? Picture of the black hole. Whoops, not hole. Well, they got the right thing anyway. Picture of the black hole data drives. She had to process all of that data. Those are not small drives. Those are not your average hard drives. She had to custom make she basically had to have custom hard drives made because Google and Facebook might have hard drives that size. But that's a lot of data. So if we have to wait for that virtual machine to spin up once to do that, it's not much of a wait to process all the data she has on those hard drives. And spinning up a virtual machine to print up hello world or spinning up the same virtual machine to process all that data is going to take the same amount of time. So it's small things in Java seem, again, Java is for big things. Like that delay there. We had to start a virtual machine before we could get the words printed to the console. It's a long wait in this case, but what was the number on her data? How much data was there in the picture of the black hole? 3.5 petabytes. So if we have to wait that same amount of time we just did to print hello world in order to process 3.5 petabytes, it's a lot better in that situation. And it's the same amount of time to spin up the Java virtual machine. So an example of that waiting. Okay, so there's our software would work the same with the other enums and stuff, just kind of a quick review on those, but it's like, all right, we got a piece of software going. Now we need to do stuff with it. Some documentation for it. We've seen that. I'm gonna tie that into GitHub here in about 15 minutes. Interface, the requirements for objects in our software. Probably a lot more stuff in an actual one. We've seen Javadocs. I'm just throwing them in here. Our greeting. The enum. So I'll put some Javadocs on here, and I'll put Chris. The list of possible ways to greet someone. Definitely not an exhaustive list in this case. And then our methods, I'll just throw a couple things on here. The constructor we probably want to use. Greeting is a greeting type data for the message to send back. And I guess we can do this too. Actually outputting the hello message. Oops. Not the only type on that line, so you go with that. And that returns a string representing the message, representing Agree. All that fancy documentation stuff, trivial in this case, but I want to talk about Javadocs at some point tonight. And the main method is our context. So far, we've seen 3 different contexts. Obviously not an exhaustive list. But if we want to spin up the Java virtual machine, the main method is the first thing the JVM does. So that's one context. But we've also seen JSP, where we embed our Java code into an HTML file, basically. And then the server looks at it, because of the file extension, the server knows to look at it and run any Java code and rewrite the HTML file before sending it to the client. And the other day we saw servlets, where we're just doing server stuff. A quick sidestep on that. Where's my source files? From what we looked at the other day, I'll come over here and if we look at the list of predictive things, the override method, we looked at the do get and do post. That's probably where you're going to start off with, because you would have the HTML class got all the way up to those, and you were probably anxious to learn those 2 methods so you can do stuff with the forms after the 153 class. I also mentioned service, and down here at the bottom, there's 2 service ones we can override. Service would cover all of it: a get request, a post request, a request. Yeah, if we need image, we have to just do a pure request. And we get a multi-dimensional array instead of just an array coming in. And there's different ways we can communicate, but service would handle them all. But you'll notice the parameters are different. And the thing I meant to point out the other day that I didn't get to, and you would probably guess this, is, well, the get's already there. So on the server, notice those parameters are HTTP servlet request. HTTP, hypertext transfer protocol, so that's client to server. So that's our 2 service methods, and we can override those. If anybody was wanting to play around with that over the weekend. HTTP servlet request, so this service has the same parameters as get and post. And the other one has servlet request. So the one with HTTP is client to server, and the other one is server to server. I meant to point that out the other day and forgot, and it passed through my mind right as I said something. I was like, I should probably point that out, because that's an interesting thing y'all might want to, some of y'all might want to click around on. Okay, so back to this. So that's our context. It's like, okay, we got the whole software running, ready to provide that to a client. We'll get to GitHub here in just a second. There's a problem here with getting it to the client, right? We're not going to give the client NetBeans or Eclipse or IntelliJ IDE. IntelliJ IDEA IDE is a really, really nice one. NetBeans is the one by Apache, and a couple years ago, Oracle, while they still claim Java, they handed it off to Apache, and some very, very nice things have been happening. It's taking up, Apache has been cleaning it up and fixing things for years, because you may have heard the name, not really known the structure of that company. The Apache Corporation is all software developers, all software engineers, except for a couple of them that got promoted to middle manager. So except for the ones that got promoted to be the boss, it is a company made up entirely of software engineers. So they are doing really, really nice things with the programming language and improving it and stuff. There's no business executives making decisions about the Java programming language anymore. We're only about 2 years into it, so improvements are still coming. But with this June's release of NetBeans, there were some really, really nice features added in here that y'all don't need to worry about the previous ones, because they've been making a lot of improvements, but they're mostly in the background. And those improvements are going to continue. But I got distracted from whatever I was talking about. Oh yeah, the IDE. We're not going to give them NetBeans IDE to run it. That's how we test it. And soon we're going to talk about telemetries. This one over here looks like it's got a stopwatch on it, or we can run profile on the project and I'll just do telemetry. Click the profile button. Which one? I thought I'd just click that. Is there another button I gotta click? I wish I'd run it. Oh. Oh, I have to click it again. Zoom button's in the way. Well, we're gonna look at this later. I was wanting to preview it real quick, but it's not profile telemetry, and then click profile. Okay, I don't know why the telemetry is not running, but you can see there's a bunch of charts and graphs and measurements on what's going on. We'll look at that soon. That's the sort of stuff we do in the IDE, right? We're not going to give that to our end user. So what's our other ways to run it? See, that being's out of the way. Also have the terminal here. I'll just use PowerShell. Have some other ones. We don't open up Kali and run it here, but it would basically be the same thing. Just need to call the Java compiler and run those. Change directory to documents / NetBeans projects. I think that's what it is. And change directory into software. What else we got here? The compiled versions are in the build file, and the text files are in the source folder. But I'm going to go ahead and go into the source and just recompile it. Well, I'll go into build. And then into our classes folder. There it is. Oh, one more. Into the software folder. Okay, there's our classes. So now we have the compiled version, so we should be able to call the Java virtual machine here. This is what happens when we hit that green button, right? Java, and which one was it? Software. Oh, it doesn't know where the thing is. Java-cp, the current directory, run software. Did I get it? Oh, it doesn't seem to know what the main project, the main file is here. So I'm going to go compile it in the other one. I started to do that at first. cd dot. There we go. Go into the source folder where those are. Then into that package. There we go. So there's our Java files. And since we've been using IDE, I'll go ahead and show it here. When we compile these, we do have to explicitly state or pay attention to the order. Because if I tried to compile that main first, Java compiler, and run software.java through it, we get an error because it doesn't know what hello is yet. There's no compiled version of hello. Clear. So need to compile that first. So Java compiler, compile hello.java, and we get an error because it doesn't know what the interface is. So you can see the order matters when we run through the compiler. The IDE automatically handles that for us. Let's see, Java compiler, let's do the interface. software interfacing rules.java. And copy and paste that. Let me try it that way. Java compiler, that file. There we go. So that one compiled. So it knows what that is. I didn't read through all the error messages, but it also would have crashed on that because it needed, the class needed an enum. So we need to do that one first. Greeting.java. That compiled. So there's the interface and the enum. So now we should be able to compile the class because we have compiled versions. The import is implied since they're all in the same package, but import is a copy and paste. Wherever we type the word, it's like import greeting, the greeting enum. It actually, when it compiles, it actually grabs that other one and copies and pastes it in place of that word, those words we have in the file. So that really is a copy and paste when it gets to the compile time. So that's why those have to be compiled first. Then we can compile our class. Why are you throwing error this time? Did I spell that wrong? Let's see if this fixes it. Nope. I'm not sure what's going on here, but it kind of expresses the point. We're not going to have the end users do this, right? I've been using Java for many, many years, and I'm not sure where this problem's coming from. It might take me a minute to dig it down because they're in the same package. It's compiled, but for some reason it says it can't find it. Definitely not something we're going to ask our end users to do. So what we need to do is build a version of that software that we can give them. Over here, let the compiler handle all of that ordering things, because there's some other stuff, figuring out where stuff's located. If we didn't explicitly state import, it will add that in, which is probably what's going on there, but I'd have to dig around and waste a bunch of time figuring that out. I think the point was made that we're not going to ask somebody to do that when they run our software. So what we need to do is actually build this. So over on our project name, which is here, if we right click, there's this build option or clean and build. I always like to hit clean and build. That'll erase anything previous. And now if we go in here, we have to go to the actual folder. This is why I use an AMP project in the class, because there's a lot less folders. It would be 10 minutes of clicking through folders to find that. So now we have this distribution folder. We didn't really look at it beforehand, but the file type right here, we have an executable jar file. It also made as a README. That's something new Apache just added. That means when you build it, you automatically get a README file. I haven't even looked at the new one. What's it say? Oh, it explains what the jar is. Oh, and here's how we run it. They even gave us the instructions. So this is the instruction to run this software. So now there's at least a much easier thing to put in our terminal. We need to go to the correct directory and type java-jar. That's the Java equivalent of an executable file. If you aren't aware of it, an executable file is actually a zipped folder but everything is machine language, so a human can't unzip that and look at it like we're used to with other folders. Same thing here. A jar is actually a zipped folder, but it's all in machine language, so we can't really unzip it and look at it like what we would normally think of with a zip folder. Oh, and they even give us some nice instructions. To distribute the project, zip up the disk folder and distribute that. There's probably more if I turn on WordDraft. Let's see what else is there. Yeah, so this is something Apache just added. So instead of figuring all this out on your own, it just automatically shows up every time you build your project. So they're moving forward with Java. There are some very, very nice things that Apache is putting in here. There's a number of reasons why that company's name is spread, and it's not just because they make really great software. They have a really great approach to everything they do, and like including the instructions directly. So yeah, they give you the instruction to run it and how to do this. So that's what we need to do. So we'll zip up to distribute this. What we do is zip up this folder, compress to a zip file, and distribute that. So I'll do cut and paste over into my delete folder, over my normal working space, and extract it over here. There we go. And now the software, if we double click on it, what happens? It doesn't run from a double click. Be nice if it did, right? You can configure your stuff to do that, but there's still a problem with double clicking, which will kind of relate to, yeah, if I just go to command prompt, I'll go up to the terminal, open command prompt here in this folder, and then type in that command they said to type in. Oh, if you did not see what I did there, just in case, because this is a software development class, a file explorer on Windows has the address bar. So anytime you get an address bar, we can push Alt-D, as in the second letter of address, and get up there, and then it knows the regular path variables. So anything that we can just type in a command prompt and get it to start. So command, Chrome, I use Sublime text editor, so I can type Sublime there, or SUBL, it's abbreviated. Anything that we can type in the terminal that it would know, we can start the software here. So if we type CMD or PowerShell up there, it'll automatically open that right in the folder we're at. Might as well point out that that's an important part of software development, because like I mentioned a minute ago, when we click that green button in NetBeans, what it really does is run this instruction on the background. So type Java -jar, the Java virtual machine, run a jar file, which is kind of the equivalent of running an executable file. That's when you might have heard more often. And then the name of the file. There's no spaces in it, so we can just type software.jar. I believe is what was in those instructions. Yep. Type software.jar, and they automatically inserted quote marks. It's a terminal, so things are space delimited. So if you have spaces in your names, make sure you drop it in quote marks. Sort of a standard there. And when we run that, our software runs. That's not what that's probably still not what we're going to ask our end users to do, right? When our end users to be able to just double click on something. And usually what we're going to have the end users double click on is a batch file that will run this. Because this is a simple version, but usually our software is going to depend on things, right? We're going to depend on the images that go on the buttons for the GUI. We're going to depend on the files for the database. We're going to depend on a lot of things. And can we really trust the users to not delete those and be certain that those are going to be there? So what we really want to do is make sure those files are in place before we run our software. So it's best to do this from a batch file, and this is a software development thing, not just a Java thing. Anytime you're writing a program, no matter what language you're in, Java, Python, C#, C++, Rust, Kotlin, the list goes on and on and on, right? No matter what programming language you're on, you don't really want your user to start that directly. I always like to make a big deal out of this because this was never mentioned in a single programming class I took. Everywhere, anywhere, whether it was a programming class or programming was a side note, they never talked about what to do when the program was finished. And it took longer than it should have to figure it out. So I like to cover that in the classroom. The first thing is you don't want your user to start the files directly. What you want your users to do is start a small script that, like a terminal script that will crash gracefully, and they won't even know it if it crashes. Unlike a big, huge piece of software, they'll notice when that crashes. The terminal script will crash gracefully in the background, unbeknownst to the user. So we have the user start one of those that checks to make sure all the resources we need are in order, and then it starts our software or recreates the resources. What I usually do is I use GitHub as a working spot. A couple things are finished projects are still on GitHub, but whatever repository it's on, I'll refer to that repository and grab the resources if they're not there. So that if they're not there, it just takes a couple seconds longer to start up because they have to be downloaded. And that way the software is going to run every time. Hopefully that logic made sense because the process of doing that is kind of long for a classroom, but the process of the sentence to explain it is very, very short. There's just a lot of typing involved in that. So if you haven't seen batch files before, usually we start with the line echo all. Oh, whoops, sorry. At echo all. So at echo all just means we're not gonna show every instruction in the terminal as this runs. Behind the window, I'll just leave the window showing for now. We'll deal with that when we do installers, when we come back and look at a formal installer later. We would write an if statement. PowerShell's nice there because command prompt, so our batch scripts, oh, we should save this. And when we save it, give it the .bat extension. So this is software .bat, short for batch file. Or if you're on a Linux machine, .sh. Macs actually have .command, but most people just do a shell script on Macs as well. PowerShell is PS1, but the shell scripts, the command scripts that Mac actually has that nobody uses because they just use a Linux shell script and it runs fine. And the batch files, those were all written back in the 70s. Programming in general has changed quite a bit since then. So when Microsoft updated to the PowerShell, which is a modern scripting language, so our like if statement to check for resources looks like it would in every other programming language that we still use. But I just figured to start with a batch script. Oh, and PowerShell was one of the things that Microsoft definitely did right. So Linux and Apple both just abandoned their plans to make a modern scripting language and use PowerShell. So PowerShell works in every system as well. Every once in a while, Microsoft does something very, very well. They do sometimes it doesn't seem like it, but every once in a while they do something great. And PowerShell was one of those. They were the first ones to make a modern scripting language for the operating system control. And they did such a great job at it. Apple and Linux just abandoned their projects to do the same thing. And like, okay, we're going to use Microsoft's. So you can always use PowerShell on any system and have a modern scripting language. But for us, we check for resources, the old style selection and looping and all that. I'm just going to go ahead and run it here. And then we type our command instructions. So the command we typed in to run it was java-jar. And here I'm going to put the full path to that software because This is the one we'll make a shortcut to here in a second. So I'm gonna come over here and copy this. Wait. That's not what I meant to copy. Okay, it was trying to copy to where, since we just opened command, it was trying to copy that. So I'm going to copy the address to where this is, the absolute address. Copy that and paste that in the batch file. Then / software.jar. So just the whole absolute file back to it. Oh, I don't have any spaces, so I'm just going to take out the quote marks to deal with those backslashes. It's Windows, so we use backslash, which means we need a backslash to escape sequence. If you have to do that inside of a string / is a backslash. Again, I think everybody's probably seen that before at this point. If you're on a Linux or a Mac, it's a lot easier because then you have forward slash in your address. But I didn't have any spaces, so I'm just going to take off the quote marks. So there's that same instruction to run that. And I use the absolute file path, which if we're in the same directory, Java virtual machine, a jar file, %cd%, would do the same thing. That's one of the differences between command prompt and bash shells. In bash on a Linux or a Mac or Zeesh or Fish, any of those, CD means change directory. So it's an action that we carry out, but in Windows command prompt, CD is current directory. So it's a variable we can use. So when we actually type that in Windows, we're actually just changing the value of that variable. So we can also use it that way, / software.jar. Those two lines are equivalent. Just to show you that CD one, but REM for remark is comments. I'm going to comment out the second one. We only need one, and we only need to start it once. Just going to show, I think it's going to stop afterwards. Let me go ahead and run this. Oh, where did I save that at? I thought I saved it in the same folder, but I don't see it here now. Okay, I lost track of that file. Oh, I saved it over in the NetBeans project. That's where I wanted it. I want it with that distribution. There we go. And this is software.bat, short for batch. So a batch file is all your command prompt instructions in one file. So you can run a whole bunch of them at once if you haven't seen that before. That gives us something we can double click and run. Oh, it is stopped. So I'm going to add in the keyword pause, which I guess I could do it after the comment. That would make more sense there. Since all we're doing is looking at the words, there we go. If there was a GUI or something that would open up, it would open up the GUI and start running, and then that window would close in the background. You'll have probably seen that happen with software, right? That black screen flashes past. That's what's going on. You're not starting the software directly. You're starting a batch file that confirms resources are in order, and then that starts your software. And pause prints out that press any line to continue. So it looks like it works. Another really useful thing. Yep, that's exactly what that does. So it's always nice to learn stuff. Gives us a way to start our software. This one's just a terminal thing, so we need to keep the terminal open. Put that pause line at the end. But if you had a GUI, it would start the GUI, and then the GUI runs independently. Because really all we did was start the virtual machine. Another big advantage here is notice that came with the software thing. We have the batch file. And then this is what we want to give the users. Except for one thing, there's actually another step we want in here. Another one of those things nobody ever pointed out to me along the way. And it took way longer to figure out than it should have. We right-click and go to properties. There's a limited number of properties here. Only so many things we can adjust. And that is a very specific thing, right? I switched to the big view, large icons. We have that gear icon, which indicates internal workings on the Windows system, sort of thing we don't want to go change those properties up. But what we do have lots of what we do have lots of control for the properties on is a shortcut. Which I don't know where Windows 11 moved that. So if I go to the old option, create a shortcut. Windows 11 moved the create a shortcut button. I don't know where they moved it. And on that software one, if we go to properties, then we have lots of control over the properties. In particular here under shortcut, this button that you probably want on your what you actually give to the end user. That change icon, right? We might want to do that. Do I have any icons? I'm just going to click one of the ones there. I'm going to give it a picture of the world that was built in. I'm not sure if I have any ICO files. Sometimes you can override it with other image data types, but usually you need an ICO, but that's just load your PNG or your JPEG into a converter and it spits out an ICO file. And then that's not the one I clicked on. Let me try that again. Properties, change icon. Right. Oh, well. I must have messed something up on my computer. I'm often making changes. There's definitely not showing the icon I clicked on. I clicked on the world looking one, but then that is what we want to give the users to put on their desktop or start menu or wherever they're going to put it. To put it in the start menu, there's a folder it has to go into under Windows. I think it's under System Apps. There's another folder in here and another folder in there, but it'll be automated when we look at installers. But there's a folder way down deep in that C drive Windows folder that we have to put that in order to get that there. If you're on a Linux, it's the in the Etsy, it's in the Etsy folder on Windows or on Linux, and one of the non-writable ones to get to our start menu. And then that gives us an icon to start it up. And that's the one we want to give to our users. I wanted to cover that in class because nobody ever mentioned that in any programming classes I took, and it took me way longer to figure that out than it should have. I kept having to just trial and error, do different things. So my software did the things that I expected a piece of software to do when I installed it and opened it up. It took a lot of trial and error to find that. And hopefully that makes sense why we want to do all those things. We don't want to just have the user go to the terminal and compile the Java code and run it that way. So build the jar file, create that shortcut, all of that stuff. I'm going back to NetBeans. One more thing, we didn't do the documentation. So on software, if we right click, generate Javadoc. So we got the Javadoc files out. That's really all we needed from that. And the reason I wanted to make sure I do those, I thought this was going to finish up about 15 minutes ago, and then we have 20 minutes to talk about GitHub, but we'll talk about, I think everybody's been doing okay with just basic uploading, downloading GitHub and stuff. So one thing I do want to show you on GitHub is where you can host your documentation right there. So when this generated that, here in our example, we got our folder and then we got our Javadocs with all of this stuff, including this index file. So whenever a server navigates to this, it's going to automatically open that index file, unless somebody went in and changed it, because we can control that. But by default, it's going to open that index file. So it looks like that's what we want to put up there for people to find. And if we want to host it right on GitHub, it needs to be in a folder called Docs. Or something I have documentation on. This one, I think, has documentation. So we need this folder Docs. And inside of that, I put the Javadocs here. And this index HTML file, all this does is redirect into that folder, the Javadoc folder. I'm going to change the name of Javadocs for our example here, but I wanted to show you all this because your SDEV 153 class probably did not cover redirecting to another folder, to another site. So it's in the chat room. Copy and paste that. Hopefully it's obvious. The only part that would need change from that is boilerplate code, except for what site you are redirecting to. And here it's just redirecting into the Javadoc folder at the same level and then the index file there. So all you have to do is just change that part to the URL you want to redirect to. So before you leave tonight, make sure you copy and paste that code and you'll never have to type it. It's useful if you need it. Alternatively, I don't like that page. I'm too used to the launch page, I guess. Yeah, that way you never have to type it. It's always the same except for that one line. Alternatively, you could just rename this as Docs. Okay. Rename that as Docs so that when that goes on GitHub, GitHub will know what to do. There's an index file inside of there. And then make it our repository. We can do all this from the terminal, from the Git GUI. I was going to talk about those some. Personally, I like to go to the website first because, well, it will check the name. If you type the name in, it will just use that name, and then that could cause a problem. If you go to the website, it checks it first and then gives you a green check mark before you can continue. So it's always nice to see that. I'm going to call this software. So on the website, it automatically checks it. I like to go there. And the description, public, private, README, Git ignore, we'll see that later in the semester. And a license, all of that stuff is a lot of parameters to put in there, but we probably want those. The quick description, the short description, what shows in the Google search results if the Google box recommends your software to somebody. It's the short description, not the long README. A class example of what to do when software is finished. So we get that short box is easier to deal with here. Add in a README, which will automatically start with that, but readmes.md file, a special kind of markup language, which GitHub has extended a .md file to also accept HTML because people are used to that. I don't know if I'll have time to cover .md in this class, but it's an easy thing to look up. Y'all know how to use Google, and it's always a good idea to go ahead and set one of the license, Apache license, the GNU license, the MIT, BSD. Those are the most open source. It's like, yeah, this code's free to use. I'm not liable if anything happens. Download it, copy, paste it, modify it, make it your own. It's like, this is just out here for the world to use. So it's good to have a license on there and create it. We can do all that from the terminal. I usually like to create it here and then go to the terminal for the upload. We've seen that. I'll do an abbreviated version. So I'll go over to the terminal, change directory into documents / NetBeans project. Into software. Let's start with there, change it to the source directory, and one more, I think. And then into that package. Oh, then that's the package that I want to upload, the source code. I don't need to put compiled code on GitHub. Right? Usually for the class, we've mostly just been putting all our stuff up there. We don't need all of our stuff up there. All we really need to save is the source code. We can recompile it later. If we hadn't hit that error, I would have shown something real quick here where I know for certain that I have a different version of Java on my Kali virtual machine. So if I tried to run this, just type Java and then the name of the software on the Kali machine, it would crash because it was compiled with the later version. I just compiled it with the latest version of Java, but my Kali virtual machine has 2 versions earlier of Java. So if I compiled it on the Kali machine, it would run on the new one because backward compatibility is held. But forward, they did not have forward compatibility when they did Java 7.1, I think. So it's on that machine. But either way, I think you'll kind of see where the point on that is. So we just want that one. Let's see. Slash. Go back up here and into the delete folder. I always like to make a new directory, something called git stuff. So make a directory and then go into that. We could have done it right there in the NetBeans project. We can permanently tie our project to GitHub. Over the years, I found I like to have a different folder where I can copy and paste into instead of having that direct link. But a lot of people do like the direct link, so that's your own personal style. But from this point on, you could have done this on the actual project. We need to initialize it for GitHub, so we type our git instruction. Let me clear. So from this point on, you could do that in your NetBeans project. Some people prefer that. I just found I like to copy and paste it for that last final human check instead of the automated processes. Git init for initialize and then dot for the current folder. Just make sure you are inside the folder you want connected to GitHub when you do that. Git init and then dot refers to the current folder. Kind of like dot refers to the parent folder. So now we have that, we can connect to the repository. We want to create a remote connection. So git remote, add an origin, and then the origin is the repository, which you need to type it in. So it's the same as the URL, but it has the .git extension. Or if you go to the green button, it's the thing on the copy and paste here. If you copy that and paste that in your terminal. So we formed a connection, and now we can pull down the repository. Git pull that origin we just connected to, and then whichever branch we want to pull, the main branch. So I grabbed all that stuff, and that's what I do when I grade your homework. I pull it down. We can pull stuff all day long. You only need permission to push to the repository. GitHub's the main place to grab open source code, so you're welcome to pull anything you want from GitHub anytime you want. You sure it's not working?
It's just asking if it's like Bosch or
Oh, okay. Probably because it's the first time you connected to that one on that machine. I probably already bypassed that on mine. There is some setup the first time, but afterwards, GitHub will recognize you. I also want to make sure you, on your machine, download Git and this, this software here, Git SCM, that has a whole bunch of background things. I don't know if you'll be able to install it on the school's machine. It should be installed on these machines already. But that has a whole lot of background things and better security measures built in and things like that than the original one that Linus Torvalds built in whenever it was, 1997, I think. Oh, and now we have that. So in my delete folder, there's the basic Git stuff, the license and the README. That's all that's there for now. I'm gonna go ahead and copy the distribution folder that has that shortcut and everything. So I'll copy that, paste it in there, and then I'll also bring in the source code. So a little bit, like, we don't need everything in that project. There's the source code and the release, and then that final shortcut that we're actually going to use. The batch file that we use to run it. So there's all the parts we need. So over in the back in the prompt, that folder has changed. So we want to add some stuff to it. So git add, I'll do doc again. Git add the current directory. And yeah, it'll GitHub uses the Microsoft carriage return line feed. Usually there's not a difference. Sometimes there is. Remember, line feed just goes to the next line. Carriage return goes to the next line and to the beginning. Usually it doesn't make a difference because on a computer, there's nothing on the next line. So the only place it can go is the beginning. But sometimes there is something there. Sometimes the next line isn't null or void. There's actually something there, so your cursor will be in the middle somewhere if you just use a line feed. So once we have those files, we have to commit to the changes. And when we make the commit, we have to add a message, some sort of short name for this commit. The example commit, I'll just call it that. Make up some name so you can get back to it. It's a repository, so we can get back to any previous version. You can always roll back the clock on it. So it's got all that stuff to do, and then the opposite of what we did to get the repository, we want to push the origin back on the main branch. Should just take a second for something this a small project like this. But those are the lines we want to use. I'll put them in the chat room again. Oh, so you can copy and paste it. So that one's always the same. This one changes. Here, I'll do this. That one you'll need to put in the particular URL you want to deal with. But again, a copy and paste thing. Then copy. Make changes. And after you make changes, add them. And commit to those changes. Work. And then obviously the message that you're putting in there would change each time. And after the commit, push it back up there. And the first couple lines, you can grab any code you want from GitHub that way. We can pull in from anywhere on GitHub. Everything there is open source. So again, make sure you copy and paste those before you leave tonight. That's the terminal instructions. We're coming back over here. Oh, we have all those changes. Oh, I forgot that docs folder. So probably want to do there's the docs folder up there. For anything in the classroom, I'll show you here that remember we can use the buttons here. The limit here is 100 files. So that's fine on these. If you're interested in game development and make something in say Unity, you're probably going to be way, way, way past 100 files. Just with the automated background stuff. If you make something using the Gradle packaging system, instead of Maven, you're going to have way more than 100 files because instead of one great big manifest, they have lots of little manifests that have one line each. But for the most part, everything in class will just be well under that 100 file limit. Or move your files over less than 100 at a time. Kind of works the same. So I'll bring over docs. And one thing left to look at this evening, and then we'll wrap up. Once again, you can add the message thing here. That's where you type the same thing as the git commit -m goes right there if you want to give it a useful name. If you don't, it'll just default to file upload. There's a lot of stuff on GitHub. So along with our code issues, so bug reports go here. This is a public place. So anybody that uses your code can come here, and it's like a forum where you can, well, it's a forum. They can post bugs they think they found, and you can tell them when that bug is fixed. Because as developers, we know our code. We know how to use it correctly, so we often don't catch every single bug because other users their intuition might have them do something different. Get insights on it, like the history of it. Dependency graph is a good one. There's no manifest, and there's some reference material here to learn about manifest is built right into it. Security measures. Last thing I wanted to look at is under settings. There's a lot of them here. We have a repository name, under issues, all that stuff, pull request. Oh, it's not under settings. I didn't see the one I was getting ready to click on. It's over here somewhere. You can turn on a chat room to make for a better bug reporting forum. If you want, there's a bunch of different options there. I don't see the button the option I was looking for. Is it under here somewhere? Nope. Oh, pages, there it is. So if you go down to pages, this used to be on the main setting. Pages, GitHub will allow you to host basically one small site to put documentation for that project. You can put whatever you want there. It's intended to be for documentation, and you're gonna have documentation for the project, so hosting that on GitHub just makes sense. So we can deploy from a branch there, and the main thing is it just has to be in the folder called docs. And notice that it is currently disabled. Select a source below, select a source to enable the repository. So we go down here on the button that currently says none. Switch that to the main branch or whichever branch you want, and then your stuff will be in the docs folder. And when you do all that, hit save, and it'll update everything. And custom domains that are new, I haven't used those. Custom domain language servers on the site other than this. And I was looking for the URL to copy and paste. Does anybody see a URL on here? Well, there's this, but there should be another part to it because that goes to all of my GitHub repositories. Or it should. Well, I guess I have to do a custom domain. Software. Let's see if that gives it to them. Okay, they've updated that, so you have to type something in the custom domain name. It used to just generate one automatically, but I haven't been there in a moment. And if we right click here, there's those Javadocs we just put together. So you go to settings and then pages, set what branch it's reading those from in the docs folder, and then give it some custom domain, and it will generate that site for you, which you probably want to copy over and put in the read. Seems like a reasonable place for it. Maybe a little bit more descriptive than just pasting it in the README. But that's probably good for the class example. So that's kind of what you want to do when your project is finished, which for most of the homework, it's not going to apply. But hopefully for your final project, you think y'all are all planning on something big and nice that you want to brag about afterwards. So you're going to want to do that with your final project. You can start setting up for it now and thinking about that. But make that, don't launch the software directly. Once you build it, make a batch file that launches it, and then make a shortcut to that batch file so that you can change the icon and have an appropriate looking logo and all of that. That's just an important thing for releasing software. And then on GitHub, use the docs folder and go to settings and pages so that you can post your documentation right there on the repository where the stuff's at. And there's more stuff, I think it's here on the whole page. Over on the right-hand side, you'll notice there's other things like packages and releases. So when we get to the end of the semester, we'll see about making an installer and actually putting our release here. This is one of the places you can download a .exe file from. And usually that's going to give you all sorts of error messages if you try to download an exe file. Can't email them, but a code repository is someplace the computers expect that final executable version to be downloaded from. We'll see releases later. What we would download on the release is that distribution folder. Or the installer, the fancy way to automatically copy and paste that distribution folder. So a few software things tonight. Does anybody have any questions about those? I see head nods in the classroom here. Okay, I assume 5 seconds of silence means no questions. So that'll be it for this evening. Make sure you copy and paste that stuff that I put in the chat room there, because that is boilerplate code. And it is copy and paste over and over and over again. If you haven't memorized yet. Otherwise, you all have a great break, and I will see you when we get back.